I thought it would be quite useful for us to just take a step back and look at what we've covered so far, give you an idea of the 2 units that we've just finished before we move on to, say, the programming side of things, and later on this week, perhaps give you an assessment to check your own understanding of what we've learned so far. Now, we've covered data representation, we've looked at multimedia, we looked at compression, we also looked at things like networks and the internet, which rounds up the communications unit. So this lesson is all about covering the topics and giving you a few questions and discussing possible answers. Hopefully by the end of this lesson, you'll have a complete overview of the sections covered so far. Of course, if you are absolutely sure that you understand all of the things listed on screen, then you might as well just skip to the questions, which will come after each section, and attempt those. So you could pause the video there and attempt answering those questions. So let's look at data representation. You should have understood the difference between kibi and kilo, mevi and mega, gibi and giga, tebi and terabytes. You should be able to convert binary, denary, and hexadecimal number bases, and of course convert to binary coded decimals. You should be familiar with ones and twos complement representation for binary numbers, be able to add binary numbers and subtract numbers as well, especially using twos complement. You should be able to understand that if you have two 8-bit numbers, and sometimes when we're adding, things might go into overflow, an extra one that goes into the 9th bit, and that can cause problems. And of course, you should be able to understand the practical applications of binary coded decimals and hexadecimals, so calculators, HTML color codes, MAC addresses, and so forth. And finally, you need to be able to understand why we need ASCII, extended ASCII, and Unicode, and what are the advantages and disadvantages of each. And you should also be able to understand that, say, if you had a word like harrow, when you convert it into binary, it has to be kept in the same order. So you use an ASCII character set and you convert harrow into the relevant binary codes. These are in the same order as the original word, and then when they have to be translated back, they are put back into the same order. You can't have W coming in front of H and so forth. Now pause the video and have a go at these questions, which should cover this part of the syllabus. Start by looking at the binary integers which are using 2's complement form. State the equivalent denary values. So you can see 0100, 1111, convert them back into denary. So these are already in 2's complement. So straight away you can look at the first digit and you know one is going to be a positive integer, the other is going to be a negative integer, and you can work it out. The third part of the question, where you have to write the integer minus 53 in 2's complement form, requires you to first work out what 53 is and then flip it and then add 1 to it to work out the negative component. Similarly, when you're looking at part 4, you can write the maximum possible range of numbers using 2's complement form for an 8-bit binary number. You have to give your answers in denary, so you need to let me know what the highest number would be. So plus, for example, 56 and minus 56. So there might be a range of numbers between positive and negative. So work that out and give that answer to me. Part B focuses on writing a denary integer 798 in a binary coded decimal format. That's pretty straightforward. And similarly, you need to convert the binary coded decimal number back into a denary number, which is the next stage, followed by giving one use of binary coded decimal numbers. So these are the type of questions you'll be getting in the assessment and in the exam. So just get familiar with those. In the multimedia section, you'll need to focus on bitmap encoding using pixels, file header, image resolution, screen resolution, color depth, or bit depth. You need to be familiar with the definitions. You need to be able to at least have 2 key points for each. So you need to know that a pixel is the smallest unit that is used to create an image, and you need to be able to focus on the file header, and you need to focus on what goes in the file header, and similarly you need to know the image and the screen resolutions and so forth. You should be able to perform calculations to estimate the file size for a bitmap image. So if you're given 1000 by 1000 image in 24-bit color, you should be able to kind of work out what the file size is. So 1000 times 1000 times 24 bits. And then you can work out whether it's in megabytes or megabytes and so forth. You should be able to explain the effects of changing elements of a bitmap image on the image quality and the file size. So what happens when you reduce the size or increase the size, and what's the impact on the quality? So artifacting and general loss of quality, you should be able to explain that. You should also be able to explain the terms image resolution, color depth, bit depth. So the greater the bit depth is, the greater the file size, but also better the quality. And similarly, when you go into vector encoding, using drawing objects, properties, drawing lists, all of those terms need to be explained. You should be able to give an example of when to use a bitmap image or a vector graphic for a particular task. So anything that requires realism, you go towards bitmaps. Anything that requires scale, you'd probably go towards a vector encoded image. Sound representation and the focus on sampling, sampling rate, sampling resolution, analog and digital data conversion. You should be able to explain what sampling means, the waveforms, how you take snapshots at various time intervals, and it's an approximation. All of those kind of things need to come into play. And finally, you need to be able to discuss the impact of changing the sampling rate and resolution and the effect on file size and accuracy. So the greater the sampling rate, the greater the sampling resolution, the greater the file size, but equally the greater the accuracy of the sound representation. So let's look at a few questions. So here you've got a context-based question. A software developer is using a microphone and the sound editing app to collect and edit sounds for his new game. When collecting sounds, the software developer can decide on the sampling resolution he wishes to use. Start by explaining what sampling resolution is, an approximation, all of that kind of approach. It's one marker. All it needs is a simple definition. The second part of A, describe how sampling resolution will affect how accurate the stored digitized sound will be. So you need to talk about the number of samples over a particular time period, the sampling rate, the number of bits used, the sampling resolution, and all of that kind of thing. Part B is all about images. So you need to talk about image resolution, what would happen if a developer is using a 16 color bitmap image, how many number of bits would be used to encode the data for 1 pixel of his image, and then you would need to calculate a file size for 16,384 pixels by 512 pixels high for a 256 color bitmap. All of those kind of things you need to take into account. The bitmap image contains a header. What kind of items would you find in that? And finally, you will need to give some features of a sound editing app. These are pretty straightforward. The ability to have different kinds of tracks, the ability to export it to different formats, the ability to edit, trim, add sound effects, and so forth. Now, this should give you an idea of the kind of questions you'll be asked for this particular section. So just be aware, it could be anything to do with definitions, so you need to revise those, to calculations. So have a go with these questions, and of course, if you're stuck at something, just let me know. Next up is compression. Here you need to justify the need for compression, of course, to save bandwidth, to reduce file sizes, because obviously memory is expensive. Even if you talk about storage space, eventually it will fill up. Just think about what happens when you buy a new phone over a period of 2-3 years. It all gets filled up with all sorts of things. And then if you didn't have that, it will fill up a lot more quicker. So saving space, saving on uploading and downloading transmission bandwidth, all of that is part of the need for compression. And then you also need to be able to give examples of the use of compression, especially lossy and lossless. You should be able to justify compression methods for a given situation and how these apply to text files, bitmap images, vector graphics, sound files, and so on. Finally, you should be able to explain the process of run length encoding, especially that it's a form of lossless compression, and you should be able to work out some examples. That's basically what comes up in typical exam questions. So on screen, you see a few questions on compression. As usual, pause the video and have a go. You should be able to explain what is meant by lossless and lossy file compression. Lossless, the data is recovered, all the data is recovered. Lossy, some data cannot be recovered. It's eliminated in the process of compression. You should be able to give an example of a lossless file format and an example of a lossy file format. So MP3s are lossy, you can focus on that. FLAC audio obviously is lossless. You should be able to describe how music picked up by a microphone is turned into a digitized music file in a computer, and how different frequencies which the humans can't hear are often eliminated, and so on. You should be able to explain why it's necessary to compress stored music files and describe how the music quality is changed depending on the kind of compression you use. So if you are trying to send a file via email, then obviously you're probably going to use a lossless format because you want to save on both file size and transmission bandwidth. But if you are perhaps working in a studio where you don't have those constraints of transmission or size, you'd probably be looking at lossless compression. And you should also be able to explain what happens when you play around with the different types of sampling rates and resolutions and what impact that can have. So MP3 obviously gives you 90% compression. So what happens when you have a 16-bit MP3 or a 24-bit MP3 or something which operates at 320 kilobits per second to something that works on 80 kilobits per second. So all of that comes into play here. You should also be able to explain what is meant by run length encoding and describe how it compresses a file, be able to give examples. Question 4 is more to do with bitmap and vector graphics. It's more relevant to the previous section, but I decided to keep that in here since this was a different set of questions, and you can see how the sections are actually interrelated. So the question could be a typical question about bitmaps or vector graphics, or it could be about the type of compressions used to store bitmap and vector graphics. Remember, vector graphics can also use lossless compression because vector graphics can often be stored in XML files, which can be text files, so you need to use lossless compression there. Next up is networks, and this is a massive section with a lot of different types of hardware devices, so you need to spend extra time covering this particular one. Actually, you could probably make an assessment just on networks, and that would be enough to take over an entire lesson's worth of assessment. Anyway, here you need to focus on the benefits of networking devices, the ability to share data, communicate, collaborate, and share software and devices in a network. You should be able to explain what LAN, WAN, MAN, and PAN are, the differences between each of those. You should be able to look at client-server and peer-to-peer models, discuss the roles of different computers. So one acts as a server, one acts as a client. In peer-to-peer, everybody is equal. So all the nodes are exactly the same. You might have one that keeps track of what's going on in the network in a peer-to-peer model and all of that kind of stuff. You should be able to explain what happens in a sub-network, especially in the client-server, and that comes in a bit later as well, especially in the CSMA, CD, and all of those kind of approaches later on. You should be able to justify the use of a model for a given situation, discuss the benefit and drawbacks of each of these types of client-server and peer-to-peer models. Similarly, you need to talk about thin clients and thick clients, especially in a client-server model. Topologies also come into play, especially packets transmission between two hosts in bus, star, mesh, and hybrid topologies. You should also be able to justify the use of a topology for a given situation, like when to use bus, when to use star, and so forth. Similarly, when you're looking at cloud computing, you should be able to discuss public and private clouds and the benefits and drawbacks of cloud computing itself. Finally, you're going to move on to the hardware side of things. You need to discuss wireless and wired networks, the use of copper cable, fiber optic, radio waves, microwaves, satellite, switches, servers, network interface cards, too many to list there. So you can look through all of those. And finally, the role and function of a router, especially over the internet, and the Ethernet protocol itself, and how CSMA CD comes into play to avoid collision detection. And the last part in networks is obviously bit streaming, especially real time and on demand, and what the impact of bit rates and broadband speed has on bit streaming. So what happens when you talk about leechers, seeders, peers, all of those kind of things. So on screen you see a few questions, and I'm not going to go through these step by step, but these are pretty straightforward, and most of these are going to be dependent on your knowledge of definitions and how it works. There's nothing to calculate apart from maybe working out what's the best thing for a given scenario. Like, if I think question number 4 is there, where you look at a building with 20 floors, what would you recommend? Is it going to be wireless or a wired network? And you need to work out what the difference is. So it's 20 floors. Are you going to have a cable connection? Lots of cables. Both can be justified. So they're looking at your understanding of the topic itself. Okay, so pause the video, have a look at these questions, and do get back to me if you have any concerns with any one of them. Most of these are going to be very, very straightforward. The last section that we covered was the internet itself. So you made your network, and then a lot of networks are connected to each other and they form the internet. So you should be able to explain the differences between the World Wide Web and the actual hardware, which is the internet. You should be able to focus on the infrastructure point of view, PSTN, public switch telephone networks, dedicated lines, cell phone networks, and I think to a certain extent satellites as well. So how do IP addresses come into play here? The formats of an IP address, including IPv4 and IPv6, you should be able to talk about that. You need to also be able to talk about things like circuit and packet switching. You should be able to talk about subnetting, how an IP address is associated with a device on a network, how that comes into play, both as static and dynamic addresses, which will come a bit later on, and what is meant by public and private IP addresses, especially in the form of a network. Like, the school has one IP address, but then you might have subnetworks within the schools which are hidden away from prying eyes. So the whole world thinks that we're sending data to Harrow, and when it comes to the main computer, the main router, it's then broken down and passed on to the relevant devices on the network, which could be based on MAC addresses. So you need to discuss the security implications of both, and obviously static IP addresses and dynamic IP addresses we covered a bit earlier. Finally, what's the role of the uniform resource locator and the role of the domain name service, and how these allow a user to access content over the internet. So you need to be able to explain the entire process of the user typing an address in the browser, and the browser using a DNS to work out the IP address, and then going to the IP address, making the connection, the server sending the HTML data, and so forth. You should also be able to explain what happens with the HTML data and its relationship with both JavaScript and PHP. It's not a major thing, but you should be able to identify things like identifiers and common programming constructs like if and totals and counts and all of those kind of things. So as usual, pause the video. We've got quite a few questions, and again, most of these are going to be definition based. A few are going to be your ability to work out what happens when you have a class A, B, or C IP address. So you need to kind of go back to that lesson and get familiar with what the differences are between the various different types of network classes and how IP addresses are actually constructed. That's going to be one of the most challenging type of questions you will get in this. The rest are pretty straightforward, when most of these are going to be definition based. It's only those class A, B, and C bits, the IP addresses, the subnetting, that's the part you need to really focus on. So look at question number 2 here. in a bit more detail and get back to me if you're not sure about how to answer these. Okay, that's a bit of a long review lesson, so do get back to me if you're not sure about absolutely anything on here. And the assessment that you're going to have later on this week will probably focus on some of these areas. We're going to start a new unit in the next lesson, which will focus on the programming side of things. However, do go through these questions in preparation for your assessment later in the week. That's all for today. I will catch up with you in the next lesson.